All right. It is my great privilege to introduce your speaker today, Andreas Stefik. Andreas has been, he's sort of the perfect person for this kind of event because he's been doing various human factor studies in programming language design for over a decade now, trying to bring, I would say, light where there has been a lot of heat on topics, for example, like the use of type systems. How effective are they? How useful are they? But even more importantly, I think Andreas has been a conscience for our community because virtually none of us has ever done anything to think about the accessibility of our programming languages, and in particular, the accessibility for people who are visually impaired and blind. And Andreas has been leading this charge for many years now. And I think that's just a really profound contribution he's made to us. I'm really happy to have him here. One thing to note, if you are seeing Zoom the same way I am, you're probably seeing a full screen slide. And on the right, you're probably seeing a panel where you can see several of our faces. But Andreas is going to end up using much of the screen. So you probably want to click on the leftmost thing which says hide thumbnail view so you can get as much of the screen as possible, especially as he starts to use the whole screen. So with that, Andreas, thank you so much for waking up early and coming to join us. Take it away.
Yeah, no problem. And thanks for the invitation. I actually really find the idea of a PL and HCI summer school really compelling. So thanks for putting it on and sending me an invitation. So thanks Sriram and everybody. As he said, I'm Andreas Stefik. Everyone calls me Stefik for whatever reason that just kind of stuck. So just that is what it is. It's like Madonna, but not nearly as cool. So there's that. I'm going to be talking today about programming languages, but also sort of the observation that humans use these things. Obviously machines do too, but so do humans. And that's kind of a big deal for a bunch of reasons. So to kind of give you a little bit of background of who I am and sort of what my perspective and my bias is, I'm a computer scientist. I invent programming languages, but I'm kind of a black sheep. I don't really publish in any one community. And the reason for that is because I care very deeply about humans that use programming languages. And the thing is that I define human to be very broad because it is very broad. So for example, this might be very young humans that are maybe 5 or 6 or 8 years old, and you might publish work like that in the computer science education community. I care about older humans or humans that are in the professional setting, and that might be people like in the software engineering community they're very seasoned. When you really think, oh, and I also care about people that have disabilities or that have other demographics, right? They're human too. And their needs are sometimes often very different than what some other people in the community has. And it's interesting and fascinating. Methodologically, we do a lot of stuff, but oftentimes what we like to do is run what are called randomized controlled trials, which is not actually the topic of this talk at all. But nonetheless, it's sort of one of a bag of tricks of methodological procedures to sort of provide a level of rigor. They're basically a way to have checks and balances to make sure that you're not, people aren't committing fraud, people are taking into account certain kinds of construct validity problems and stuff like that. That's sort of their purpose. So very briefly, let's talk sort of about how software dev kind of used to be. And when I say used to be, I mean it's somewhat tongue-in-cheek in the sense that, like, obviously, we've had sophisticated editors and sophisticated tools for doing programming for a very long time. It's not new at all. But you might imagine that you had a text editor and then you might have a console, at least theoretically. Now, you might also think that this is not sophisticated, but in fact, text editors are incredibly sophisticated tools. If you've never tried to build one, it's quite a feat to be able to get it exactly right. But as sort of things have moved on and time has moved on, environments have become very specialized. You know, in Microsoft Word, for writing just plain old English, especially for non-experts, there's all sorts of features that are sort of built in to try to make things easier. And modern development environments do the same thing. And oftentimes they disagree on the details. They have different features that they provide and stuff like that. But at the end of the day, the sort of goal of development environments is to make them easier to use. Now, I will say very briefly, for a lot of these slides, I'm going to be talking about a picture that's on the slide. And there's a reason I do that. And that is because if you are blind or visually impaired and you see these slides and I don't tell you what's in the picture, you may not know what's on the screen. So on the screen right now on the right-hand side is a picture of NetBeans 8.2. It's a little older version. And it has a number of features related to source code like coloring, little tree navigators, little consoles, a play button so that you can run your software and things like that. Now, that sort of environment like NetBeans is really for professional programmers that work in industry. But in fact, there's a lot of people that are not always taken into account in the academic literature that do different kinds of programming. So for example, data science programming is really common in the scientific community. And so on the screen right now is an example of something called RStudio, which is sort of designed for people that are not necessarily trying to make a product that they release to the wild. Their goals are different. In RStudio, in the top left, you see that there is basically a spreadsheet, and it has data in it. This actually happens to be real data, but that's not the point. And in the bottom left, you've got basically a console. And then on the right-hand side, you can't see it all right there, but there's different ways to do plotting. There's different ways of having package management and stuff like that. And the goals of people that use RStudio are often closer to, I'm trying to find out the answer to a hypothesis. I'm trying to find out evidence for or against a hypothesis, as opposed to, I'm trying to like make a website or something like that. So data science programming environments today are actually quite sophisticated, but they're also very different because they're for a different kind of person, right? And then there's computer gaming. So on the right-hand side right now, what you see is a picture of Unity 3D. And Unity 3D is fascinating. If you've never downloaded it and given it a try, it's incredibly sophisticated. It's got all sorts of property windows to handle 3D and 2D animation. It's got all sorts of simulation type tools. You can hook it up into like external cameras. Like I know they shot the new Mandalorian Star Wars series through it, through all sorts of some specialized stuff. It's got properties windows for physics. It's got different asset things. It's very visual. You can drag and drop it. It's a very sophisticated way to manage specifically computer gaming. And even with young students, so sometimes when I give talks, there's sort of a disconnect. Like sometimes people, you know, if they're thoroughly entrenched in a community that targets older people, like software engineers, they sort of are sometimes at least dismissive of younger students. Whereas sometimes as well, the opposite is true. Sometimes in the computer science education style communities, they forget that these tools have to be used in practice. So this is an example on screen of what's called Snap, which is a tool for younger people. On the left, you see there's these blocks, and typically you drag and drop them. Sometimes you can use keyboard shortcuts to move and manipulate them as well. And then on the right-hand side is sort of an animation window where you can do various things. Now, one question that often comes up is, well, why bother to worry about children at all? It's obviously the case that older software engineers end up writing most of the software that we use in practice, which of course that part is true. But in fact, one of the reasons is because it's often required by law that students learn to code. So for example, in Nevada, SB 200 requires that every child is able to take computer programming, has to. It's just part of their education. And as such, if it's going to be required by law and the state's going to be putting out resources to try to make sure that every child learns to code, then it behooves us to try to do a good job with that, in addition to making it accessible to people with disabilities, which is also required by law. So what's the big picture point? In the last 30 years, computer programming has changed significantly, which is not that surprising. I think this, if you've followed anything related to programming in the last few years, that's probably not exactly a surprise. But how accessible are these advances? And what does it even mean for software development environments or programming languages to be accessible? And what is accessible? So oftentimes, disabilities isn't taught that much in college education programs in computer science. So sometimes I think it's helpful to take a step back and ask ourselves, what does accessible mean? Both from the perspective of humans and also from the perspective of the technologies that they use. So I'm going to spend a little bit of time this morning talking about both of these things. I'm not sure if I should follow the chat or not. I'm guessing not. Okay. Disabilities come in a lot of forms.
I think you can ignore the chat, Andreas. We'll let you know if something comes up that you need to do.
Okay, thank you. So first of all, let's talk about vision. So oftentimes, while the categories are much more nuanced than this, I want to give you a big picture. Vision, we oftentimes think about blind, people that cannot see at all. Sometimes people use the word non-sighted for that. Low vision, these are often people that use magnification or make things bigger, stuff like that. And then colorblind, which is a surprisingly large percent of the population, especially in men, for whatever reason. There are hearing disabilities. This is like deafness and hard of hearing. If you've never interacted with the deaf community, there's a lot of interesting cultural things, oral traditions, sign traditions. There's a signing only Starbucks in Washington, D.C. It's really fascinating if you've never been. There are speech disabilities. This is like the ability to speak at all can be an issue, and also stuttering. There are mobility impairments. This would be one you probably know, wheelchairs, like the ability to walk, stuff like that. But also the ability to use your hands and arms can be a really big deal in programming in terms of trying to use programming languages. I'll show you some examples of that later. There are neurodiversity disabilities. Now, interestingly, the term neurodiversity is kind of debated a little bit, and oftentimes people debate what goes in this category, and what actually goes in the category isn't really that important of a scholarly discussion. But nonetheless, most people that I know in the community include things like autism or dyslexia, short-term memory loss, and 100 other potential conditions as well. And there are many people that have multiple disabilities, and this often requires some careful thought, like deafblindness or speech and mobility disabilities. And it's important to understand that when we think about these disabilities, we often define them in part by function. Now, this is not a clear spectrum, but nonetheless, it's sometimes helpful to think about that way. So for example, with deafness, you might have someone that uses sign language, captioning, or lip reading. Well, that's not necessarily function, but nonetheless, depending on one's function, one might fall into one of those categories, right? And also as well, even if you have a particular function, you might just be in a particular tradition. So a friend that I know from another NSF project is actually deaf, but that individual doesn't actually sign at all. It's not that unusual because she's in the oral tradition. And even with blindness, for example, one of my old students can actually legally drive, even though he's legally blind, and he moved to North Carolina specifically because the laws in that state allow it. Now you might say, holy crap, that's terrifying, but the reality is his vision is complicated and it's just good enough that he can drive. And imagine how freeing that is, looking at that level of function, and even from the state's perspective, deciding should this person be able to drive or not. Now, in terms of vision, there's a lot of tools that people use. So the first on the screen is magnification tools. And on the top is a magnifier built into Windows. And you might think to yourself, cool, it makes things bigger. But actually, it's not so simple. Some magnifying systems inside of the computer do, in fact, just make things bigger. But there's a problem with that. And the problem is that oftentimes things can become very pixelated when that occurs. So another approach to magnification of the computer is actually to re-render anything that's on the screen as it enlarges. And you're probably familiar with this because video games do this a lot. They make a mathematical model of the scene and then they re-render based on the math as opposed to just the raw pixels. On the bottom is a flat out magnifier that connects to a computer and it just makes things bigger. There's also Braille displays. Now, and tactile graphics. On the right hand of the screen are Braille displays. And Braille displays, if you can't see them, are basically like a big, long, almost pad, like a little thin little pad, and it has these pins that pop up. And those pins give you Braille information about what's on the screen. Now, there's all sorts of complexity to using these particular things, but the idea is that you have pins going up and down as you navigate like web pages and text and stuff like that. In the middle is a Braille printer. It does exactly what you think it does. And on the left is swell paper. If you're unfamiliar with swell paper, it's basically like a form of paper that kind of like pops up a little bit. So it's like you can feel a graph, which is the top image, or on the bottom there's a little bird, and you can kind of feel the outline of that. Now there's complexity there too. You might ask, well, how do you know if they can feel it, and in issues like that? But these kind of tactile graphics have been pretty well studied in the academic literature. They're imperfect, but they're a lot better than nothing. Okay, and then we've got screen readers, and these cannot be described in English. I have to actually show you these. So give me one moment, and I'm going to pop up a screen reader. Okay, in 1 second.
Type search. Notepad. Note. Untitled notepad. Text editor. Edit multi-line blank. Desktop.
Okay.
Shows video layouts window.
Can someone confirm that they can hear that?
We hear that perfectly.
Yes, perfectly. Thank you,
Everyone. Alert.
Okay, thank you.
Desk.
Okay.
Show small from hide. Desk.
The first thing you have to know about screen readers.
Josh has joined the meeting alert.
That Josh is
From Daniel Wong.
you have to be able, you can press the left control and it will tell it to be quiet. But as I use this, it's possible as Zoom kind of puts in things, it might speak over me. So I'll try to silence it, but it is the reality. So what I'm going to do is I'm going to write a line of code.
I-N-T-E-G-E-R.
I'm typing it extra slowly just so you can kind of hear it. Of course, when I actually use screen readers, I never type it this way.
Space, A, space, equals, space, A, space, dash, space, 5.
Now, in my head, I read
Mohammed Tahei has
something like integer A equals A minus 5. But let's take a listen. Oops.
From
Zoom is talking over it. Interesting. Hello.
Joseph Cutler has left the meeting alert.
Everyone, do not
Application
type in
contains
the chat. Or do you want to
Yeah,
go
it
to
does.
the Zoom?
It's pretty aggressive.
star untitled star integer vertical 0 used to change star untitled integer equals a 5.
There we go. Okay. Whoa. Okay, I'm gonna restart it.
Exit NVDA.
The reality of screen readers is they can be a little buggy. I didn't even. Interesting.
Star blank integer equals a 5.
Okay, it's a little fast.
Blank integer equals a 5.
It said integer equals a 5. One more time.
Blank integer equals a 5. Integer equals a 5.
Here's the weird thing.
Exit.
Things to know. Number one is when you read lines of code, screen readers skip characters, right? And as a person that is used to screen readers, this is not a big deal. There's all sorts of ways to get the characters. You can turn on punctuation. You can do all sorts of tricks to make sure you're there. But inexperienced blind users, very common, especially if they're young, would not know that. And in addition, this is the default way of reading, and it's based upon reading English text, not reading code. Now, that's all I'm going to say about that for right now. I just want you to know that it's a tool that talks to you. There's different kinds of it: Windows, JAWS, NVDA, VoiceOver, stuff like that. And in addition, that these kinds of tools have quirks. That's really all I want you to get out of it for this second. We'll talk a little bit more on it later. Okay, for hearing disabilities, this can also get pretty complicated. First of all, there's different kinds of ways of communicating, and this is extremely important to the deaf community. American Sign Language is the most common, but actually for programming languages, there actually aren't signs for every aspect of programming. We did a workshop with deaf and hard of hearing people last summer, and it was really fascinating having people make up signs on the spot and do stuff like that. There's other variations, and I won't go into all the details, but there's Pidgin Sign English, plain old English signs, signed exact English. There's something called the oral only tradition. There's something called cued speech, which has to do with like using your hands to imply phonemes. There are different technologies like smart hearing aids. If you've never looked at the design of how the hearing aids are put together, they don't just make things louder. That's not really how they work. They often do things like manipulating formants or adjusting frequencies inside of like the thing. And when you think about it, that makes sense because a human ear may not have attenuation across the frequency band equally, right? So smart hearing aids have to do special things. There are cochlear implants, which I'm very much so not an expert on, but it's like a medical procedure to try to improve hearing. And there are FM systems, which basically can get information from like a stored place that sends it to you so you can plug it in. These are really common in like movie theaters, often have them, churches sometimes have them, places like that. Now, in terms of accommodations, on the screen right now is a picture of sort of a classroom. And on the right-hand side is a woman that's using, I can only assume, ASL. And she's up in front of the class signing to the whole class. Now, in the bottom right, there's actually a man, and he's touching the hand of another man. And that might sound a little bit strange, but that's because he's using a tactile sign. It turns out there's a special sign language called tactile sign for people that are specifically deafblind. It's not known very much, and you need to pay people sort of a specialized thing in order to do it, but nonetheless, it is pretty well known. And on the left-hand side of this image, there is what's called a CART system. And basically, it's just a real-time captioning, very much so similar to the kinds of things that we see built into Google Slides and a PowerPoint today that's on the bottom of the screen. Okay, then there's mobility disabilities. Now, in terms of mobility, the first one is that you might use speech input. That's very much so possible. There are ergonomic keyboards. These look like keyboards, but they are shaped differently. So like they often have breaks in them. They can move up and down, stuff like that. There are large keyboards, often if you have handshaking and stuff like that. And there also have keyboard guards. These are sort of like rubber kind of overlays on top of the keyboard. And they often, if you have your shaky hands, like with cerebral palsy or something like that, then sometimes that can help it so you don't accidentally press keys. They're sort of used for things like that. Or, you know, like me spilling coffee, but that's a whole other issue. There are trackballs used pretty commonly amongst the community. And then there's a thing called mouse keys. On the screen, what you see is a bunch of arrows that looks kind of like a numpad. And that's because you use the numpad to move the mouse left and right. Now, when you think about it, that's actually really tedious to be able to move the mouse with these like mouse keys type things and then press buttons on numpad to do it. But it's a heck of a lot better than nothing. And if developers only have mouse support in their tool, sometimes you don't really have a whole lot of a choice if you have a particular disability. Now, this particular one is one of the more interesting. On the left is a man, and he has in his mouth a little device called a sip and puff. And a sip and puff, it's red, like you basically put your mouth on it and you breathe into it and you suck out of it. And then on the right-hand side is what's called a Wivik, which is basically a Windows virtual keyboard. It looks like a keyboard, but the letters are all in the wrong spot. And that's for reasons I'll get into in a second. And these things often scan, meaning there's a little red cursor and it moves along. And when it moves along, you could use the sip and puff as sort of a switch to tell it to stop. Now, in your head, you might be thinking, oh my God, trying to program with that would be very slow and very tedious. And yes, it would. But nonetheless, it's a heck of a lot better than nothing. So it's an option for people if you're a quadriplegic. So here's one other case study that I think is fascinating. There's a young woman who gave me permission to talk about this named Anna Kirkpatrick, and she uses a very different mechanism. She's a PhD student in math at Georgia Tech. And on the screen on the top left is something that is a virtual keyboard, but she uses it very, very differently. And that is Anna uses her stuff through eye trackers. And if you look at the keyboard on the screen, it's interesting. All of the characters are also in the wrong spot. They're not QWERTY. They're not like the same thing as the virtual keyboard before. And the reason for that is because Anna got very sick of using this standard traditional virtual keyboards. So she ran a statistical analysis of all the keys that she used in their frequency to try to minimize eye distance. She's a mathematician. Minimize eye distance so that she could type more quickly. She mostly types in LaTeX, and so you can imagine why she would want some of these like little special characters and stuff like that. On the bottom right of the screen is basically like a hub that has a series of USB connections to it, and these are all connected to switches. In Anna's case, what she does is she basically presses various kinds of switches and buttons, and those speed up certain kinds of operations. The way she described it to me was things like, if I'm in a tutoring session, I might have a switch that is keyed just to say, yeah, good job, or things like that. Oh, by the way, that's called OptiKey is the name of that tool. Pretty interesting. Now, finally, there's learning disabilities. Now, you might think learning disabilities are very different from all the others, but in fact, as we'll start talking about in a second, that's actually not as clear-cut as you might think. Oftentimes, if you break accessibility support for one of these disability types, you end up breaking them for all of them or many of them. So in terms of learning disabilities, usually we often talk about the kind of tools that they have. Some are visual thinking tools, brainstorming tools. Everybody uses those, but they're common in that community. Visual analysis tools, this particular one's called Tinker Plots. It's sort of like a data science-y type approach for, I think, effectively middle school students. There are a bunch of dots on the screen and they kind of live move and stuff like that. And interestingly, many in the learning disabilities community also uses screen readers. Now they use them differently. They can see and they can hear, but you can imagine if you have a reading disability, that a tool that could read out to you is very important. This is one reason why if you break support for people that are blind, you actually break support for people that have learning disabilities as well. So you're breaking support for a lot of folk. One more example. Closed captions, they only impact the deaf, right? Well, it turns out they do not. In fact, closed captions actually are used by the blind because there's often a transcript and they can download it and use it with a screen reader. They often help parents. So like this picture on the screen is my daughter sticking her tongue out. She's 2. If I'm in a hotel and I don't want to wake up the rest of the family and I'm watching a video or something like that, I might have closed captions on. They help non-native speakers, not even necessarily with disabilities, and they might help those just in loud or in really soft environments. So oftentimes the point is technologies for people with disabilities often actually impact a lot of people, even if you don't think about it. Final thing I want to mention on these kind of like tech ideas before I jump onto how this sort of impacts PL and the environments around them is there's a couple accessibility guidelines that are good to at least know exist. The first one is called the Web Content Accessibility Guidelines. You need to know that one in part because in some places, depending on what you're doing, it's sometimes required by law. And then there's also Microsoft Accessibility and Apple Accessibility, although those standards aren't used quite as terribly much, even though they're well done. Okay, now I want to do something sort of strange, and I'm going to actually time it. Oftentimes in online sessions, it can't be quite as interactive, and that's just the reality. So what I'm going to do is I've put on the screen a picture of the environment Scratch. And what I'm going to do is I'm going to give everybody 15 seconds to look at it, and I'm going to describe it first. On the left, there's a series of 3 tabs, code, costume, and sounds. Then there's a thing that says motion, and it has a bunch of blocks in it. These are sort of like little, almost Lego blocks that you kind of link together, and that's how you code. On the right, there's an adorable little cat that just is asking to be animated. And then on the bottom right is a picture of like what they call a sprite, which is basically like a picture that you can manipulate. Now, what I want each person to do is for the next 15 seconds inside the chat, I want you to just think of anything that would not be accessible and to whom for this particular environment. If you're not comfortable typing in the chat, then just think about it in your head. 15 seconds, go for it. All right, so I heard a couple, and I know I only gave you a short amount of time, and that's not enough time, but that's okay. And I heard things like fine motor control, the animation itself, those are definitely true. Color for easily determining structure of code, text in the video, that might be true too. Colors in the left list, scrolling to the bottom of the list of blocks, all those are actually really good thoughts. Okay, let's keep going. Okay, so what's the point? Again, at the high level, people with disabilities use a variety of tools and systems. Technologies and strategies for one type of disability often helps the other. If you break support for people with disabilities of one kind, you often, without even knowing, break it for everybody else too in different kinds of ways. So what does this have to do with programming environments and programming languages? And it turns out this is kind of complicated. So first of all, here's just some sort of rules of thumb that like, if you're not doing these things, you know that you're not accessible. Number one, if your application is mouse only, not accessible, definitely for sure, it's just not. People with mobility impairments often use keyboard mappings, and so do people that are blind and visually impaired, amongst others, and just people that like keyboard shortcuts like me. For environments that are used in K through 12, this is actually really important because there are laws that protect the civil rights of young children. So for example, just like it would not be acceptable for a child just because he has a different skin color or because he's female, I'm sorry, he's female, because of this person's gender or something like that, that would not be acceptable to exclude, but it's also illegal to exclude children because they have a disability too, which makes sense. They have civil rights like anybody else. So in K through 12, not having this kind of support if your stuff is used in the classroom is actually against the law. But this is tricky because schools sometimes have a lot of trouble getting technologies that off the shelf are accessible because programming language designers and companies and stuff like that only sometimes taken into account. On the bottom right is a picture of Blockly, which is a technology used across many block languages. And that one itself is really not accessible today, although I know their team is very slowly working on it. Now, another thing as well is that programming languages themselves often have a myriad of challenges related to being accessible. And I'm not going to talk about all of them because there's a whole ton, but I want to give you a flavor. So first of all, about 10 years ago, I think Sriram said it was about 10 years. I think he's about right. I kept hearing in peer review, formal peer review, that there was a tremendous amount of evidence on human factors of language design. I heard this over and over and over again, and I could not figure out why, because when I observed the academic literature, I couldn't find any reliable data coming from a tradition of psychology or reading medical studies and such. Like the level of rigor was an order of magnitude too low to try to solve the complexity level of a field like PL. So eventually, a lot of us in the literature started looking to see like, well, what kind of checks and balances do they have? What kind of methodologies do people use? And here are the common ones: not having a control group, not gathering any data at all, not testing with people other than the authors of a publication, trusting anecdotes almost entirely. And then in addition, this is still true today, not even having a formalized evidence standard. So if you don't know what an evidence standard is, that's because they don't exist in computer science, even though that's a huge problem. In some areas, evidence standards are even required by law and were put on top by Congress on top of the scientific community. That's happened several times historically, notably in the early 1900s in the medical community, again in the 60s. And today with the education community, notably in 2003 with No Child Left Behind, but especially the tiers of evidence model that came out of the ESSA in the Obama administration in 2015. So many scientific communities actually have standards, even legal ones, for the kinds of evidence that you have, but in programming languages, somehow it's gotten missed. So this was actually a friend now, didn't believe these kind of claims that were being made, that there wasn't much evidence, so strongly that he spent about 4 or 5 years, carefully reading any paper he could find in every single major academic journal, conference, whatever he could do, to try to formalize how much evidence there actually was. The fellow's name was Antiyani Kayanaho. And then he classified and created a database about how much evidence there was, and shockingly, it was about 22 randomized controlled trials between 1976 and 2012. Now that is very low for a scientific community, many orders of magnitude. To put in perspective, a community like the medical community between 1990 and 2001 was in the ballpark of 110,000 studies that followed basic methodological procedures. Now this is a long story in and of itself, and I won't beat a dead horse, but the idea is this. Historically, programming language designers have gathered tremendous amount of detail on the technical aspects of programming languages, and this stuff is very thorough and rigorous. But in terms of human factors, it barely exists at all. There's almost no human factors evidence at all. Now that has been changing. It turns out over the last 10 years, a number of us that have noticed this, quite a few of us now actually, have been gathering some evidence on human factors, like what impacts people. One of the topics is related to static typing. There used to be this long debate, do the types actually help people? Turns out that's true. There's multiple randomized controlled trials. They've been conducted in multiple countries. They've been conducted under multiple kinds of conditions, like with or without IDEs, with or without code completion, multiple languages. Studies have been done by other groups that aren't even using RCDs, like Christian Bird's work, which basically comes out to the same answer. There's studies even on generics that, even though they're not that well studied, they seem to be relatively positive. The actual study is kind of complicated, but never mind that. The point is, static typing does help, and we even have a pretty good guess as to why. And it kind of makes sense. If you don't have the type in your code, you have to go hunting for it. And it turns out when you find differences in time, oftentimes that difference basically matches the time that you spent going to try to find the type that you're supposed to pass to a function. Or at least that's what the studies seem to show. Now, besides types, there's also syntax. And it turns out syntax as well, because there was no real evidence, you might think one language did much, much better than another. But in fact, what actually happened was a lot of people just kind of copied C-style syntax for other languages, and individual characters and individual words seem to be the problem, and it's not always obvious which ones they were. On the screen right now is what's called a token accuracy map. A token accuracy map is a kind of complicated statistical procedure for calculating which words cause problems and which words don't as humans use programming languages. Now, this particular study is slightly old now, but what it compared was if I took programming languages and then I compared their syntax to a language where the researchers literally rolled dice and chose the syntax randomly, how do they compare? And it turned out in this study, there was no statistical difference between Java, Perl, and a randomly designed programming language called a placebo language. Now, when you think about it, you might think, well, that's weird, but why would that be? But think about it. If you're listening or you're looking at code, oftentimes in a language like C with C-style syntax, it might sound like this. For left paren, int I equals semicolon, I less than 10 semicolon, I plus plus right paren left brace. Now, from the perspective of a human, when you actually talk to younger people that haven't programmed before, they don't know what the word for means. In fact, they often think it means the number 4. A lot of those parens, they get in the way, and we can calculate how much. And then in terms of words like having the semicolons, you might think that's a big problem, and it is, although it's actually relatively minor. The data from Paul Denny shows it's less than 3% of errors, so it's not that much, but it still exists. Stuff like that. Matched braces are even weirder. It turns out with matched braces, it turns out the brace on the left is actually the problem, but the brace on the right is an issue, but it's not quite as bad for whatever reason, quirk of the data, I guess. So, but the claim I often hear when I say this is, well, just switch to language X. X is better. And I will tell you, I have heard this claim for every variation of the letter X that you can possibly imagine, right? I've heard it for Python, Java, all sorts of stuff. Any kind of language you can imagine, I'm sure I've heard this particular claim for. And oftentimes the problem is people don't realize that a lot of these languages actually share syntactic properties, and sometimes those are okay and sometimes they're not. So for example, here's Python with a similar piece of code. This one is for I in range, left paren, len, left paren, sum array, right paren, colon. And interestingly, all these little matched parts, those are a big problem. Lots of data on that in the literature. The word for still doesn't mean anything. So even if you like one language or another better, it still doesn't get past the fact that they shared some of these properties that turned out to not be very effective from existing languages. And no language is really exempt, including the work that we do. Oftentimes there are word choices that are very tricky to figure out. You actually need data to know what the right choice is. But that's programming languages. And you can imagine if you have disabilities, you're listening to those through audio, which we'll do in a minute, that this gets really tricky. But in fact, you don't have to just think about from a disabilities perspective, just the language itself, because it turns out you also need to interact with the language. And one of the features that's been shown to help, especially with blind users, is this concept of abstract syntax tree navigation. This work largely started through this woman named Katie Baker's work on AS tree navigation in Eclipse, which was a paper from Kai a number of years ago. She showed basically that you can jump around and navigate. And then that was expanded on by this fellow named Amir Armali, and he wrote his dissertation on navigating code sort of on the web. Basically the same result as Katie, but also confirmation that it was true. And then there's a paper, and I actually think, if I remember correctly, the Tree Room was involved in this as well, but they did a paper, Emmanuel Schanzer did a paper on accessible block languages, and it has a tradition from Katie Baker's work, but the thing that's really lovely about it is that they really carefully mapped out all the little keystrokes that you press and all the ways that you navigate between the pieces. And that's so important for that community. Those tiny differences can make such a huge difference in terms of productivity for that kind of navigation. And we actually largely copy some of that stuff even in our own tools because it's really good. And then finally, I'll just mention, you can imagine as part of programming, you don't just navigate on the code. Oftentimes you navigate the code for a purpose. And so there's a fellow named Sina Baram who actually worked with Emmanuel, and I work with him very heavily too. And he's done some work lately on GitHub. It's not public yet, so you can't see it, but he's been working on how to navigate diffing structures on top of GitHub, which is fascinating because you often want to do that. As a professional developer, at least, you want to know what you changed or what other team members have changed as well. And so he's been working to make that more accessible on the web. The point here is that it's not just like the individual word choices and stuff like that, although that does matter, but it's also this idea that you need to basically work on anything around the programming environment. All the environmental stuff does matter a great deal as well. Oh, and one more I'll mention on this front too. When designing labels and auditory cues, like the sounds that come out for people with disabilities, but especially the blind, consider how easy it is to browse the cues. We often call this semantic prioritization. I actually didn't coin the term, but although the people that did apparently attribute it to me, even though I didn't think I called it that. The idea is this: the most important information should come first. And in addition, you have to imagine browsing this same structure over and over again. So for example, if I had a set of code and it was in a language that used the word int to describe int, and you had 10 of them in a row for whatever reason, browsing up and down very quickly would sound like int, 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 int. And the idea is you can't really browse that easily because you have to hear the same thing over and over again. And point being, the first few milliseconds of a speech or auditory cue are critical to get right. And so now we have another 15 seconds. So on the screen right now is the following. On the left is a number 9, which is a line of code. Then there's a blue box, and that indicates a modified line in a Git structure. There's the word config, resizable, semicolon. The semicolon is an error and has a red underline under it that goes all the way to the end of the line. And then it's equals true. So in your head, or you can type in the chat if you'd like, what I'd like you to do is to think about what, if a screen reader hits this line of code, what should the auditory cue be? What should it say? 15 seconds. Okay, now here's the tricky part. I won't give you all the answers, but so I've heard config equals true error. I've heard line 9 error. There can be an error tone, a beep, and read the code. That's actually really good. That one is, there's some evidence that that makes sense. Equals true error. Does this depend on context? Yes, it definitely does. Oh, what it should say. Yep, that's exactly right. Is this the first hovered line with the change? That's a good question, but I'm not telling you the answer because I don't remember. So, but let's say no. Wrong token. Okay, so these are good. I'm glad you're thinking about it. When you really think about it from a semantic prioritization point of view, oftentimes if you land on a line of code, you want to be able to know what's there. So technically it would be something like config is probably the first part of the semantic cue that you'd want. But what do you do with all these attributes? It's a tricky question. And keep in mind, there isn't a lot of strong evidence in regard to formal randomized controlled trials comparing things like this. So I think the honest answer is we don't really know for sure. We just have some guidelines to try to help us guess reasonably well. Oops. Okay. Last thing I'll mention on this regard is that sometimes when you're designing programming languages and when you're designing these kind of tools, you actually don't have to guess anymore because there's a number of scholars that have been gathering quite a bit of data. And I want to point out one that I think is really fascinating. And that's on the design of error messages. These are sort of like chronically bad. I think we all know this. Error messages have sort of been around for a really long time. They often, you know, like __ GCEDCL, : 48215, whatever nonsense people have. But it turns out human beings on the right-hand side of the screen is a % of errors fit to an exponential model. It turns out that humans fit categories of compiler errors at astonishingly predictable ways. So that graph is actually an exponential curve fit to the categories of compiler errors on every quorum ever produced on the website that we have. And like it just fits to like a glove to the types of categories that are there. And what that means is when you're designing or changing programming languages, you can actually use that exponential fit to calculate which parts of the human factors evidence you should gun for next, because it gives you clues about which things are the most important to your users, and you don't have to guess for that. And I'll mention too, if you want to know more about that sort of thing, there's a wonderful, wonderful paper by Brett Becker and a whole team out of the IDICE working group on this exact topic, and I have a link to it at the bottom of this particular slide. Okay, now there's one piece about programming languages that I want to come back to that I think is, oh my God, the captions actually say idiocy working group. That is not actually what I said, but that's really funny. The graphics, when it comes back to computer graphics, we talked a little bit about things like gaming, but how do we possibly come out with stuff that can be blind accessible that also handles graphics? So what I want to do there, I want to actually show you because it's not obvious. And there's a game on the screen with some little actors and stuff like that, but I think this has to be seen. So what we've built open VDA.
And it's Quorum. Quorum Studio 2.1.0 window. Loading window. Progress bar 4. Harvesting garden gnomes. Projects tree view. Level 3 charts test. Quorum 5 of 6.
Okay, so now what this is a programming environment that we built for the Quorum programming language. If you don't know anything about Quorum, it's got, I think, 103,000 users a year. It's used mostly in K through 12, mostly the United States, although I know there's some schools in Africa and Taiwan and places like that that use it, although I don't know exactly what for. I'm going to show you two quick things. One of them is relatively simple.
Level charts test. Quorum 5 of 6 level 3.
If you've never used a screen reader with trees and stuff, that's a whole other lecture, and I can talk about that. But what I'm going to do is I'm going to run a program that, in this case, is going to generate a graph.
Build successful in 0.63 seconds. Charts window. DT bar chart. 4 bars. 0.0 to 8,782.5.
Now,
use the arrow keys to navigate the chart.
Oftentimes when we do things like charts, when a programming language generates a chart, what it does is it generates a flat image of pixels. You shouldn't do that ever. What instead you should do is when you generate that picture, it should generate semantics about the chart that can be queried by screen readers and then adapted through the standard technologies like Microsoft UIA or stuff like that. So here's an example of how we can do that.
Unknown scale with 5 ticks, from 0 to 8,782.5. Chart area 4 bars. Bar 1, 44. Bar 2, 80%. 2 of 4, 7,051.67.
Okay, perfect. 5 minutes, that's exactly perfect.
Bar 3, 93%. 3 of 4, 8. Bar 4, 100%. 4 of 4, 8,782.5.
The idea is that you can use, when you're designing any kind of graphic, you can actually add a semantics layer, which is what Quorum does by default behind the scenes. How that works is complicated, but never mind that. And then what it allows you to do is to take any kind of visual structure. So we've also been building this into
Quorum Studio
computer gaming engines. And so my sort of dream over the next few years is to make one as sort of as powerful as Unity 3D, but fully blind accessible. And we've almost achieved that goal. And so what I want to show you is an example of how you can actually do this. On the screen right now is a 2D environment. The 2D environment, just because we haven't finished the 3D quite yet, it's almost done. And the 2D environment basically has a whole bunch of basically like dirt squares and like grass squares and stuff like that. I can then go to a palette.
Scene palette tree view. Expanded.
And I
level dirt graph expanded.
Items to the scene like grass.
Level 3 grass 1 of 25. Grass a flat, grassy tile. Minus 32.0.
I can give it information about like what is in there.
Cancelled placement. Code tabs tab control. Scene.qs tab. Scene.qs minus 32.0. Stone to water right to left, 0, 0. Press enter to select items.
I can then give information about what's even in the scene. And so we've actually we have blind children all over the country using this tool already, in part because it's kind of fun. I mean, they couldn't really do this until very recently. And the idea is that now, even if you're blind, you can make visual games. Why would you want to do that? Because then what you can do is you can make things that also, even if you have a friend that can see, can also play, but you can play it too. And so it's kind of a really nice motivating context, in addition to providing you a way that any kind of arbitrary computer graphics, no matter what it is, has a mechanism by which to become accessible. Okay, so that's just scratching the surface of the kind of stuff that you might think about with both programming languages and with these kind of development environments in general, but I hope it at least gives you a taste of the types of things that you want to think about so that you can go back and think about this in your own research or other areas as well. So thanks again for inviting me, and I hope that was at least partially interesting.
Thank you, Andreas. That was fantastic. It's very different than most of the content we've had, and I think profoundly important too. So thanks so much for that.
So Jack Galinas, why don't you go ahead?
Hello, we were just wondering, similar to just programming languages in general, when you're developing tools and for different accessibility groups, how do you make the trade-off between like being domain specific to one group or to trying to make a universal tool that's really trying to address multiple accessibility groups?
So there's two answers that I would say to that, that question. One is I would say use evidence, and that's the first one. And when I say that, I'm not being facetious. What I mean is that oftentimes when we run user studies on human beings, it could be the case of a couple of things. Number one, you might think it's domain specific, but in fact, you're not really helping people in that domain. And number two, it could also be that you're underestimating the effect sizes for each. Giving you a tangible example. Oftentimes, we run studies where we'll gather like people at different age ranges, and we'll look at the trade-offs to see what is the impact across this group of people. Like, for example, freshmen in college, sophomores in college, juniors in college, seniors in college, and then professional programmers at various levels. And we do that because it could be the case that this trade-off of like, well, once you learn it, it helps the pros. It could be that that's true, or that could be complete crap, and like it has no basis in actual fact. So let me give you an example. If you take the programming language R, it's domain specific, right? Certainly it has statistics and stuff like that. Do you think that the professional community benefits by calling a test to compare ranks Kruskal-Wallis? Seriously. Do you think that it benefits the professional community to specifically call it T-test or F-test with single letter variable names? Right? And so one of the things that we had tested relatively recently was, well, if we just take people with some programming experience, a year or two, we toss them in R, and then we take novices, of course the novices get crushed royally. But if you give them programming experience, does that training even have transfer of learning? It turns out we measured that. It turns out 3%, which is statistically detectable, but practically zero, right? And so that's interesting because the point is, with domain-specific languages, so tricky because you have to be, always want to do the same thing. Take a step back and actually measure it with each of those people that you think you're targeting to see what the size of the effect is. It's that size that matters. And you should always use a standardized effect size between 0 and 1 so that you can get between 0 and 100%. So you can say, okay, with my domain, I'm getting 82% increase over whatever I'm measuring. But when I send it to the general purpose, I'm getting like nada. And so that sort of a thing, always base it on data. Don't just guess, because it's really hard to guess, really hard. So I don't know, does that help?
And also, you brought up effect size when we were chatting and everyone else was at their tables. So I think that may be new to some folks. And
oh, sorry, yeah. Okay, so oftentimes in statistics, yeah, I do statistics all the time and have written stats libraries and stuff like that, so I'm so used to it. In statistics, there's two concepts that people often need to understand. One is this concept of p-value, and one is this concept of effect size. And I will tell you how to understand these things by discussing Bacon, which is always the most appropriate way to discuss p-value and effect size. Okay, so there's a very famous study. I always teach this in my classes because I just find the studies so lovely. Scientists, I swear this is true. Scientists have done 800 epidemiological studies trying to decide whether or not bacon causes cancer, okay? Now, by show of hands, please click the raise hand button if you believe that bacon causes cancer. Not
wait. Don't do raise hand. Do yes or no. Do yes or no.
Hand.
Oh, okay. I'm sorry.
Because I'm using that to manage the queue of questions.
They can just raise their hands on the video. It's okay. We'll just take a sample. It's fine. Yeah.
Yeah, it doesn't have to be exact. Yes or no, raise your hand, whatever you want to do. Okay, so it turns out that scientists in the medical field, they very carefully try to run their studies so that they can be compared in certain specific kinds of ways that I won't get into. It has to do with an evidence standard called consort. And what they do then is they make it so that these studies be compared, and then they measure how large of an effect is. So for example, it could be that bacon use at a certain frequency level is correlated with cancer, but it can be knocked out by other variables. So what they do is they have lots of different researchers try to knock out those various kinds of variables, and they all make it comparable so that they can try to get a global size estimate for the causation. And it's not purely causation, but it's complicated. And so what they find is that bacon use, there is a causal mechanism, and we measure it with this size of effect. It always goes between 0, meaning it has 0 relationship to the actual construct being measured, to 100%. 100% would mean, like if you had a graph and it was a correlation, it's a perfect correlation. It's not quite correlation. The math is slightly different, but nonetheless, it's a good analogy. Like it's every point is exactly on the line. By the way, if you ever see 100% or a 0% in a paper, just reject the paper because they're probably lying, right? It just doesn't happen almost ever. But the point is with bacon, turns out really teeny, teeny, tiny effect size, which is why they needed 800 large epidemiological studies. The effect is significant, but for you to actually have a problem with cancer and bacon, it turns out to be that you need to eat quite a lot of bacon every day. Ta-da, bacon does technically cause cancer, just a little bit of cancer. And they know how much.
Thank you for statistics via bacon.
Statistics via bacon.
All right, Shivan, why don't you go ahead and ask your question?
Hi, thanks so much for your great talk. At one point of your talk, you were talking about people who didn't know how to program but required accessibility techniques, so they wouldn't know what a for is. So I just want to know what's the norm here. So a lot of us, like me personally, we started off with a language that was comparatively easier to pick up, like Python, just to learn how to code. And so what is the norm for people who do not know how to code but require accessibility techniques? Do you use constructionist languages like Scratch? Do you start off with pseudocode, or do you actually jump in right into a language like Python? Just one more.
Unfortunately, the literature is not super clear. There's a little bit of data. Shreem's shaking his head, and that's unfortunately the correct answer. So I'll give you a couple examples of data that I know about. First of all, don't assume that you know which languages are easy to pick up and which are not. That's number one, because it turns out the evidence is quite complicated. And crucially, because language designers for such a long time weren't gathering data, what we end up with is when you actually measure what's in languages, oftentimes you find, and this is the language we've made, Conform, is no exception to this. It's absolutely true with ours too. You find that there are certain pieces of the language that cause problems for humans, and it's not always clear what to do about it. I'll give you an example from our own stuff that we found recently in our data on compiler errors. And this is that if you look at, we came up with this thing called token signatures. It's kind of a way, like for a particular compiler error, to calculate what the error was that people had. It's sort of a root cause finder for compiler errors, something like that. And when you do it, what you find is that the token stream, when people actually use programming languages, that people make mistakes of a lot, is ID. And what that means in this context, when you go dig through the actual tokens to figure out what they're doing wrong, is that people often capitalize the keywords when they're young. And they're not supposed to in the language. So then there's a problem. Do we allow you to capitalize keywords? Do we give you a hint? What do? Do we change the language? Do we change the error? Do we give you another indication? And then the error produced is actually produced by another programming language called Antler. And Antler's messages are not great, right? They're really terse. They're designed through this mathematical procedure, but the phrase for humans makes no sense, right? So oftentimes it's not clear. So I wouldn't assume that even if the language designers had a really good idea about what was easy or hard, I wouldn't assume no, because nobody does, right? And none of us know. We're trying to gather data to get a better sense of that picture, but it's going to take at least a generation, is what I suspect. Now, number two, I would also say that in terms of the block language versus non-debate, I think the most sophisticated evidence on this topic is by David Weintraub. He's done a number of studies on this. They're really fascinating. They're generally well controlled, but also done in the field. And the results from this study, they usually the kind of comparison that he did was like, I have some people use text and then some people use blocks, and then I compare between them. So what's the result? The answer is that in high school only, the only place it's been tested, so take that for what it is, in that one situation, blocks do increase learnability by a smidge. And when I say a smidge, we're talking effect size again. I forget the number off the top of my head, but I want to say like 3%, 5%. Someone else might remember the exact figure, but it's not much. And so the point is, we know that it has an impact on learnability, but we know it's not very large. So then you have to ask, like, well, what do we do? And then what's the impact on middle school kids? What's the impact on grade school kids? If you put it in a professional setting, which settings would it work well for? Which would it not? We just don't know very much information. So I wish I could tell you, here's the facts, but the facts are, we don't have very many facts, right? And that's sucky. Yeah.
Thanks. Michael James, why don't you go ahead?
Yeah. First, thanks for the talk. And so just as there are these specialized IDEs for the cited or specialized interfaces instead of just text editors, are there screen readers that are specific to science or engineering that have special modes or can produce special beeps or take other sound cues?
That's a great question. To my knowledge, the answer is no. It's not that you can't create one, you could, but one of the tricky things about screen reader design is that there's this difference between out-of-the-box style modes and non. So I'll give you an example. Sometimes in the literature, you see a tool, and I'm guilty of this too, because when I was first learning about accessibility, it's a mistake that I used to make. I just didn't know, right? And what you would do is instead of actually having connections through the main operating system pipeline, instead what you would do is you just output speech to the system and then say, cool, we did it. We got a bunch of speech and it is exactly the exact prioritization that we want. There's a huge problem with this. What if you're using your programming environment and you're using Skype at the same time? What if you don't want to be disconnected to the world? Well, it turns out there's a problem because if you do that and you have a custom speech pipeline, it doesn't go through the screen reader pipeline, which means you get double speaking. Literally, you have two things yapping at you at once, and it's maddening. It is absolutely unusable in every sense of the word. So the only way to do it, at least on operating systems, is to run it through the operating system pipeline. And I'll mention what that is very briefly, just so you know it exists. On Windows, this is called Microsoft UIA automation. And one of the reasons why a lot of tools and even programming languages are not accessible is because they get the UI automation wrong. For example, if you look at the modern Java FX programming, it turns out they got almost every single accessibility property wrong. Literally, if you go up to a menu, it tells you that it's like a panel. And it's like, the problem is then screen readers get, they say, cool, I got a panel, but it's actually a menu, and so it doesn't speak anything because it thinks it's a panel. So oftentimes, this is just language designers, you know, it's accessibility oftentimes doesn't get as much attention. And as well, these UIA type patterns are very complex. You must be an expert to understand them. Oh, literally, we did a hackathon with a friend at Microsoft a week or two ago to debug this one issue we were having, and we have done this for years with our accessibility pipeline. He had to very literally pull out the Windows source code and check the order of operations with the way that we were connecting to accessibility. So there's a reason this needs to be done by experts in the programming languages, and if they're not doing it, any application on top of that is automatically inaccessible. So the point is that is possible to invent, but if you invent it, it has to go through either Microsoft UIA on Windows or on Mac, it's called NS Accessibility. Otherwise, it won't really work.
Awesome. Now I'm going to see if we can do a little bit of a lightning round. We have about 11 minutes left and 9 questions. And I would love to be able to get through all of them, though of course your in-depth answers are very much appreciated, but
no problem.
Let's give this a shot. Okay. Run Chin Chin.
Thank you very much. Dr. Stefik, thank you so much for the inspiring talk. I was wondering, like, making the syntax of programming languages easier to understand, it could lower the barrier to learning the language, but it might also come at the cost of, say, productivity. Like, people might have to type out longer or more keywords to compose a program. So I was wondering, from a perspective of a PL designer, how would you balance the trade-off between language accessibility and programmer productivity?
Yeah, that's a great question. The answer is always the same: data. You measure it with both groups. Always the same answer because you don't know. But I will say too, oftentimes I wouldn't make the presumption that longer is necessarily better. there are lots of phrases in programming that are quite long, but are quite terrible. For example, Kruskal-Wallis. Think about data science. Almost always we use the mathematician's name to represent the statistical test. No one understands that unless you're an expert. But it also turns out sometimes shortened words are really bad too. Like especially there's lots of data on single letter variable names, acronyms, like people understand NASA and nothing else, right? And so the point is, whenever you're making these decisions, no matter what you're doing, use evidence because it's really hard to guess, really hard to guess.
Justin Lubin, go ahead.
Thank you, and thank you so much for that really great talk. It was very fascinating. So as someone who does not have a particular disability or is not part of a particular community, how do you do need-finding research and construct systems that can best serve other people's needs while also not imposing what one might think is best and also not acting as sort of like a savior from outside the community?
Oh yeah, that's a legitimate problem. I think that you, number one, it takes a little time. Like with the blind community, you know, there was a few years when we were first starting out where people probably had that impression that we were just out to like, I don't know, we know what's best or something like that. But the reality is you just got to keep working at it and like keep talking to the community, keep getting feedback from people. Having people tell you you're wrong is a thing, and that's okay. So I hate to say it, but a lot of it is just kind of community building and like working with people. You know, when we started doing our stuff for the blind, to my knowledge, there were 0 schools in the United States that did any computer programming at all. Now it's at least half. And like, is it that it's our stuff that really made the difference? Well, I don't know if I think so. I think part of it is that like, we got them together every year. We talked to them all the time. We answered their questions. We would work with them. So part of it is just like having a little bit of humility and working with the community. And then in addition, building some tools that get better slowly over time. The perfect is always the enemy of the good, you know?
Yeah, thank you.
Jeffrey Litt, go ahead.
Yeah, so you mentioned that sometimes these tools for people with disabilities help other groups. And it struck me that some of the technologies you're mentioning, especially around traversing ASTs and structure editors, or things like keyboard navigation, there's other motivations for these things and people work on them. And then there's also these accessibility motivations. And I'm wondering, do you think there's more room for those groups to kind of come together and trade? Do you see like room for kind of cultural bridges between those motivations?
I absolutely do. In fact, I think a lot of times they're actually the same and people just don't realize it, right? Like for example, if you build in Microsoft UIA automation, you know what else it gives you? It actually gives you a way to do automated unit testing with your UI. People don't even know that, right? I'm like, why would you? Because like it's this weird esoteric library, but it actually provides you weird things under the hood. It also can provide you all sorts of other stuff that people don't know about. And with keyboard shortcuts, holy crap, like we added in, I actually think I don't know if we copied the same keys as Streamer, but we definitely copied the same sort of procedures for keyboard type stuff. The moment I added those in, I use them every day, all day, because I can bounce around so easily in my source code. I'm not blind, but it doesn't matter. Like it's still really helpful to be able to traverse as an AST right from within the editor. It's just handy. So, you know, so yeah, I definitely agree. I think there's more to it than people think. We're all a community, you know.
Yeah, this is a great, potentially, maybe future example of a double use like captions that you mentioned.
Yeah.
Noel Welsh.
Sorry, I just muted myself as you unmuted me. A lot of people in our group think they are underprepared to conduct the kinds of studies that you advocate for. So can you recommend some resources to learn more about methodology?
Yeah, that's a good question. So there's a number of things that I would recommend. Number one is that there's a whole bunch of psychology books that talk about this stuff, but it's kind of a load to kind of do. Number two that I would recommend, and I swear this is not a resource, but it is true, is make a couple friends and do it together and make mistakes together. And I know that sounds a little bit silly, but I swear to you, as you're learning this stuff, like learning with friends is both more fun and it's sort of easier. Number three, I actually have a ton of resources on running RCTs on my website that's free for anybody. And those are based off of the consort evidence standard. And so it's very rigorous, but nonetheless, it also covers like different resources you can grab, different studies you can look at and stuff like that. So it tries to put it in sort of plain English type explanations for stuff like that. Now, besides that, there's a couple other resources I would recommend looking at. One of them is the two reporting standards that are probably the most common. One of them is CONSORT, C-O-N-S-O-R-T. And the reason you should look at this is not just because it's used in other communities as an evidence standard, but because it's simple. It's a 2-page checklist of the kind of things you should get. And don't be fooled. Just because it's on a checklist doesn't mean that these people did it randomly. Some of the things on this checklist were debated for decades in Congress, right? These things are tricky, like that you'll see a little phrase that'll say stopping conditions. You're like, yeah, of course, why would I need to stop? They're like, no, 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 that was a set of studies that came out of the 70s and did these things, and there's all sorts of stuff. The second one I would consider looking at, just for like what to report and stuff like that, is the JARS standard, the APA JARS standard. APA JARS is the psychology's version of what to report in studies. And the reason I recommend this is because it gives you a sense of the types of things you should track when you're running experiments. Now, as a final thing, if you want to go nuts and you just really want to get into the history, there's a lovely book, and I don't recommend it for learning methodology, but it's great for knowing the checks and balances and why they came about, by Harry Marks, on the history of controlled experiments. And it's called, the name is forgetting me, but it's Harry Marks, and it has experiments in the title, like the history of the RCT in the 20th century or something like that. And there's all sorts of lovely stories about why the laws changed over time, what they changed to, which specific procedures got added when and why, like standardization procedures out of John Stokes, all the crazy ethical problems in Guatemala, which is why we have our IRBs nowadays. If you've never read that, don't, it's creepy. Stuff like that. So if that stuff isn't enough, because I know that kind of went by quick, you're also welcome to email me, and I'm happy to toss you a couple links more directly too. So.
And Andreas, I have so much to learn from you about RCTs. I just also want to throw in that you're describing a certain type of study, which is quantitative.
Actually, no, that is not true.
Oh.
It turns out that the concept, see, this is actually, it's good. I'm glad you mentioned it, because this is often a misconstrued thing in computer science. People think that the RCT has a certain meaning, but in fact, the RCT came about because of the debate between field data and lab data. It has nothing to do with quantitative or quantitative at all. And this debate was done between a few scholars, especially Ronald Fisher in the early 30s. No one believed him that statistics was helpful. But there was also some field data people that were inspired by John Snow in the 1800s. If you don't know his work, he found basically that people were dumping literal poop in the water and it was killing people through cholera, right? It happens. No one believed him either, but never mind. But interestingly, that debate was ended, and it was ended by a fellow named Austin Bradford Hill. And I guarantee you, you know his work, even if you've never heard his name, because he's the guy that showed strong evidence that smoking causes cancer, right? He was the first to do that and is considered the father of the randomized controlled trial. So what did that do? Well, it turns out the randomized controlled trial is a technique to determine causality. The end. So what does that mean? It means the randomized controlled trial is a set of strong checks and balances to prevent certain kinds of fraud, to prevent certain kinds of things. So typical RCTs contain field data, lab data, quantitative data, qualitative data, coding, doesn't matter. Their goal is to determine the cause of something, not to make determinations about whether you have qualitative data or something. So even in our own RCTs, we use qualitative data all the time because it's really useful, but not all the time. And often when we take qualitative data, it's for a purpose. We're trying to rule out a particular problem, right? And so it's not quant versus qual. That's not RCT.
Got it. Okay, okay. Thank you for the correction. All right, we've got 5 more. Let's rock it through them. Will, go ahead.
Hi. So my question is, it seems like an important technical principle for supporting accessibility is exporting a structured representation of information like you did with the bar chart. And then that structure can be viewed by each person in accordance with their own abilities and preferences. Our group was wondering, what challenges did you face in that type of tool design? Like, does it make it harder to make internally breaking changes or other things like that?
That's a good question. I don't know. I'm not sure. Like, so I think that the semantics under, well, so the way that we do it in Quorum, at least, we have our visual representations, which are coupled to the hardware acceleration system, you know, just plain old normal GPU programming type stuff. And then we've got our semantics layer, which is kind of separate. And so they can be intentionally desynced if you want them to be, but there's standards so that if you have particular constructs, they're kind of the default that are in there for like a tree or a text box or stuff like that. But it can get tricky, like you're kind of implying. Like for example, in our game editor, you might think that we put in some kind of like a tree structure behind the scenes, but actually the operating system was never designed to make Unity 3D accessible. It just wasn't, right? That's just not, it's just not a thing, right? Like, so the operating system isn't like, hey, let's go into 3D mode now. We're gonna make that blind accessible. It just doesn't work that way. So what we have to do is some often pretty nasty, dirty tricks with semantics in order to make that even talk how you want. And specifically, I swear this sounds awful, but it's really true and it works. And when we talk to devs in the community, it's probably the best way to do it. We actually trick the system by force feeding little tiny bits of semantics at a time and then turning them off. For specifically the editor, it's because it's a grid, but it's an infinitely sized grid and the operating system doesn't know how to handle that. As dumb as that sounds, it's the truth. And so the semantics there can be tricky and it does take a little bit of work, but at least on the Quorum project, we've done these semantics layers for so long now, we kind of know how it goes. So when we have to make changes, it's usually not that big of a deal. So.
Andreas, can you stay another 3 minutes or so?
Yeah, of course.
Awesome. Okay, Siddhartha, go ahead.
Thanks so much for the talk. Yeah, our group had a chat and question revolved around conceptualization of code. So a lot of pedagogical tools for, that are used to teach programming are deeply rooted in ableism, say citedness with things like code traces. And this sort of feels like this might inform a basis for tooling and conceptual models of code. Is there a similar sort of standardization for, say, blind people? And if there isn't, if there's a lot of fragmentation in how they sort of think of code, how does this help, how does this affect building tools for, generating representations of code for them?
Can you say that one more time? I didn't totally follow.
Oh, sorry. So a lot of pedagogical tools, for coding, say rely on citedness, things like code tracing or like whiteboarding out things. Is that so? And this sort of informs, it feels like this informs sort of a standard model of how we might represent code to sighted people. Is there sort of a similar sort of standardization in how these things are represented to blind people? And if there isn't, if there's some fragmentation there, how does that affect how then tools represent code to, say, blind people or people with, visual disabilities?
Yeah, I think that the key with any kind of representation for the blind, at least the blind, well, not just the blind, but the blind, actually learning disabilities too, because they use the same API. It's not like Microsoft made a blindness API, they made an accessibility API, it works for anybody. Is this semantics layer. So all these ideas about tracing and all that kind of stuff, they might be put into a visual structure that you see, but like it almost feels inconsequential. They're a structure and there's just a representation visually of that structure. But for example, if you're blind and you had a stack trace, well, you can manipulate that. That's not a problem. It's just a set of things in a row, right? If you were blind and you had like a program trace, that's not really a problem. It's not a big deal. That's like a visual representation of some idea, abstract idea. And it's the ideas kind of that you feed to the accessibility system. And then there you make interactions like keyboard presses and stuff like that to go through them so that you can get them one at a time or as a clump. But nonetheless, I feel like the ideas are kind of the same, right? They're just visually represented.
Andreas, thank you so much for this. Really opened up a lot of this space, I think, for students and for us organizers who are less familiar with your work. So let's thank you again from the bottom of our hearts.